October 3rd, 2025. The date astronomers had circled in red for months. The day when 7 spacecraft orbiting Mars would turn their cameras toward the most mysterious visitor our solar system has seen in years. 7 orbiters. 2 from NASA, 2 from the European Space Agency, 1 from China, 1 from the United Arab Emirates. All positioned perfectly to capture the highest resolution images ever taken of an interstellar object. The Hera camera aboard NASA's Mars Reconnaissance Orbiter alone promised resolution down to 30 kilometers per pixel, 20 times sharper than anything Hubble had managed. This should have been the day we finally got answers about 3 Atlas. Instead, it became the day the silence started. 2 days before the flyby, October 1st, the United States government shut down. NASA's website went dark with a simple message: the agency is closed due to a lapse in federal government funding. And when the European Space Agency finally released images 4 days later, all we got was a fuzzy white dot moving across a field of stars. 1 image from 7 spacecraft. Where are the rest of the photo? What did those cameras really see when 3 Atlas passed within 30 million kilometers of Mars? And why, after months of anticipation, does it feel like someone just pulled the curtains closed right as the show is about to begin? Before we dive into what might be one of the strangest cover-ups in modern astronomy, do me a quick favor. Hit that like button and subscribe, if you haven't already. Then drop a comment telling me where you are listening from, what time it is there, and whether you think NASA's silence is bureaucracy or something more deliberate. And if you want to help grow our community, share this video on X, Facebook, Reddit, or your messenger. Thank you for always having our back. Chapter 1. The Perfect Setup. Let me take you back to July 1st, 2025. The Atlas telescope in Rio, Chile, picks up something moving fast through the outer solar system. Within hours, astronomers pull pre-discovery images from archives. Images taken by other Atlas telescopes around the world and by the Zwicky Transient Facility at Palomar Observatory. The object had been photographed as far back as June 14th, but nobody had noticed it yet. When they plot its trajectory, something immediately stands out. This thing isn't orbiting the sun, is passing through. 3 Atlas, as it would come to be known, the 3rd interstellar object ever confirmed after Oumuamua in 2017 and Borisov in 2019. But unlike those previous visitors, 3I Atlas arrived with something extra. A trajectory that seemed almost too perfect to be random. Think about the plane of our solar system. That flat disk where all the planets orbit. Most objects coming from interstellar space approach from random angles. Oumuamua came in at 123 relative to the ecliptic. Borisov at 44. 3I Atlas, 5 degrees from perfectly aligned with the plane where all our planets live. A vibe at Harvard ran the numbers. The probability of an interstellar object arriving within 5- of the ecliptic plane just by chance sits around 0.2, 1 inch 500. Now add this. 3 Atlas would pass close to Mars within 30 million kilometers on October 3rd. It would swing near Venus. It would approach Jupiter in March 2026. The combined probability of an interstellar object arriving on a trajectory that brings it near 3 major planets in sequence, purely by random chance 0.0055 inches 100,000, you start to understand why some researchers raised eyebrows. Natural comets don't typically come gift-wrapped with optimal viewing angles. But the trajectory was just the beginning. As summer progressed and more telescopes turned toward 3I Atlas, the data started accumulating. Hubble Space Telescope captured images in late July when the object sat 277 million miles from Earth. What those images showed challenged expectations. Most comets, when you photograph them, show a bright nucleus with a tail streaming behind them away from the sunday. Solar radiation and solar wind push dust and gas backward, creating that classic comet tail we all recognize. 3 Atlas had something different. The Hubble image showed a glow, yes, but it extended forward toward the sun, not away from it. The plume of scattered sunlight stretched out ahead of the object like it was pushing through something rather than being pushed. And behind it, where you would expect a prominent tail, nothing, just a faint suggestion of material that didn't show up clearly until late August. David at UCLA processed those Hubble images. He measured the forward glow extending several arcsecs. When you translate angular measurements at that distance into actual size, the bright region stretched across thousands of Cologne. But here's what made astronomers pause. The extension was roughly 10 times longer than it was wide, creating an elongated teardrop shape pointing sunward. Natural outgassing from a comet nucleus tends to create more symmetric patterns, especially when solar radiation pressure should be actively pushing material backward. The James Webb Space Telescope observed 3 Atlas on August 6th using its near-infrared spectrograph. Webb can break down the chemical composition of objects by analyzing the specific wavelengths of light they emit or absorb. What Webb found was unusual. The gas cloud surrounding 3I Atlas was dominated by carbon dioxide, 87 by mass. Carbon monoxide made up about 9. Think about every comet humanity has observed from our own solar system. They're typically water-rich, icy bodies that formed in the cold outer regions of the Sun's protoplanetary disk. When they approach the Sun and warm up, water ice sublimates, creating those brilliant tails we associate with comets. But 3 Atlas seemed to be built differently. 87 carbon dioxide is almost unheard of. Only one other comet in our records shows anything similar. Comet C 2016 R2 discovered by Pan-STARRS, which also displayed an unusually high carbon dioxide to water ratio. The SPHEREX Space Observatory, NASA's spectrophotometer for the history of the universe, epoch of reionization, and ISIS Explorer, observes 3I Atlas between August 7th and 15th. SPHEREX operates in the infrared red, particularly at wavelengths around 1 micrometer, which helps estimate the size of objects by measuring how much sunlight they reflect. The data SPHEREX collected suggested something even more surprising. Based on the amount of infrared light bouncing off 3I Atlas, the nucleus could be as large as 46 kilometers in diameter. 46 kilometers. For context, 2I Borisov, the previous interstellar comet, had a nucleus estimated around 1 kilometer. 3 Atlas, if the SPHEREX measurements hold up, could be 1,000,000 times more massive. 1,000,000 times. Allo published his analysis of what this size discrepancy might mean. He calculated that at solid density, if 3I Atlas really is that large, we're talking about a minimum mass of 33 billion tons. That's his lower limit estimate. The object could be substantially larger. He pointed out something that makes the statistics even more troubling. If interstellar objects follow a normal size distribution, we should have detected hundreds or thousands of smaller objects before ever encountering something this massive. The Atlas telescope system has been scanning the sky for a decade. In all that time, just 3 interstellar visitors, and the third one is suddenly 1,000,000 times bigger than the second. The probability curve doesn't support that distribution. Unless, of course, the size estimates are wrong. Unless what SPHEREX detected wasn't the nucleus itself, but an enormous cloud of dust surrounding a much smaller core, that creates its own problems. If 3I Atlas has a dense dust coma large enough to reflect that much infrared light, where's the tail? Solar radiation pressure should push all that dust backward, creating a spectacular tail visible in every image. Instead, Hubble and other telescopes saw mostly forward scatter and minimal trailing material. Throughout August and September, ground-based observatories captured additional data. The Very Large Telescope in Chile performed spectroscopy on 3 Atlas on August 25th. They detected cyanide CN molecules being released from the object at a rate of about 20 grams per second when 3I Atlas sat at 2.8, 5 astronomical units from the Sunday. But what caught attention was how rapidly that production rate increased as the comet approached the Sunday, the cyanide emissions scaled with heliocentric distance raised to the power of 9.4. That's an extraordinarily steep relationship. Most comets show production rates that scale with distance raised to the power of -2 to -4. 9.4 is almost unheard of. The VT data revealed something else unusual. They detected nickel in the gas plume around 3 Atlas, but not iron. Nickel without iron. In nature, these two elements almost always appear together because they're both produced in supernova explosions and get incorporated into forming solar systems in relatively fixed ratios. Finding nickel without iron is like finding smoke without fire. It happens in very specific industrial processes where nickel alloys are manufactured, but in natural space objects, it's anomalous. Then in early September, amateur astrophotographers Michael Jagger and Gerald Raymond captured images of 3I Atlas during a total lunar eclipse. Their photographs showed something unexpected. The comet, which had appeared reddish in all previous spectroscopic studies, now glowed green. Green comets aren't uncommon. The color typically comes from diatomic carbon molecules C2, which flues green when excited by solar ultraviolet light. But here's the problem. Earlier spectroscopic observations by Luis Salazar Manzano's team at the University of Michigan found that 3 Atlas showed extreme carbon chain depletion. The comet had significantly lower levels of C2 and C3 molecules than any other comet on record. If 3 Atlas lacks diatomic carbon, what's causing the green glow? One possibility: the steep increase in cyanide production detected by the VT. Cyanide can produce greenish emissions under certain conditions, but again, the chemistry doesn't quite add up. The combination of high carbon dioxide, low water, depleted carbon chains, abundant cyanide, nickel without iron, and now a green glow that shouldn't exist based on this molecular inventory. It paints a picture of an object that doesn't quite fit any template we have for natural comets. By late September, 3I Atlas had moved close enough to the Sun that observing it from Earth became difficult. The geometry placed the comet near the Sun's position in our sky, drowning it in solar glare. From Earth-based telescopes, 3 Atlas effectively vanished into the brightness. This is where Mars became critical. Mars sits much farther from Earth than the Moon. But in early October 2025, Mars occupied a position in its orbit that gave spacecraft around the red planet a much better viewing angle of 3 Atlas. As Earth lost its line of sight, Mars gained one. 7 orbiters circled Mars, each equipped with cameras and spectrometers designed primarily for studying the Martian surface, but capable of being repurposed for special observation. NASA's Mars Reconnaissance Orbiter carried the HiRISE camera, high-resolution imaging science experiment, arguably the most powerful camera ever sent to another planet. HiRISE can resolve features down to 30 centimeters from its orbital altitude around Mars. Pointed at 3 Atlas during closest approach, his angular resolution translated to about 30 kilometers per pixel. That's resolution 20 times better than what Hubble achieved when imaging the object in July. NASA's MAVEN spacecraft, Mars Atmosphere and Volatile Evolution mission, carried the imaging ultraviolet spectrograph, which could analyze the ultraviolet emissions from 3I Atlas and map the distribution of gases in its coma. The European Space A's Mars Express orbiter had the high-resolution stereo camera, along with Omega and SpyCam spectrometers for compositional analysis. ESA's ExoMars Trace Gas Orbiter featured the color and stereo surface imaging system CASIUS, plus the NOMAD spectrometer and a SEM infrared instrument. China's Tianwan-1 orbiter contributed the moderate-resolution imaging camera. The UAE's HOPE orbiter brought the Emirates Exploration Imager and 2 spectrometers, EMIR and EMASS. 7 spacecraft, multiple cameras, multiple spectrometers, all positioned to capture data during 3 Atlas's closest approach to Mars on October 3rd. Astronomers worldwide anticipated this would provide the clearest look yet at the interstellar visitor. The pieces were in place. The timing was perfect. The instruments were ready. And then 2 days before the event, the United States federal government shut down. Chapter 2: The Silence Protocol. When a government shutdown occurs, certain agencies go dark while others maintain skeleton crews for essential operations. NASA typically furloughs around 80 of its workforce during these events. Public affairs offices close. Social media goes quiet. The main website displays that standard message about lapsed funding. But mission-critical operations continue. The Mars orbiters don't stop functioning. The instruments don't power down. Data still flows from spacecraft to ground stations, gets recorded, gets stored. What changes is the pipeline for public release. NASA's raw image archives for Mars missions normally update continuously. The Perseverance rover, for instance, uploads images from its various cameras to a public server where anyone can browse through them. During normal operations, these raw images appear within hours of being taken, sometimes faster. The system is largely automated, but processing those raw images into calibrated, analyzed, publication-ready formats requires human expertise. It requires scientists to examine the data, correct for instrumental artifacts, stack multiple exposures if needed, and prepare explanatory materials for public consumption. On October 1st, 2025, that human expertise got furled. Over 15,000 NASA employees received notices. The timing meant that when 3-2 Atlas made its closest approach to Mars on October 3rd, the people who would normally process and release spacecraft imagery were at home, technically prohibited from performing official duties. The European Space Agency, not subject to United States funding politics, continued operations normally. ESA's Mars Express and ExoMars Trachis orbiter both observed 3I Atlas as planned between October 1st and 7th. These spacecraft turned their cameras toward the interstellar visitor. The ExoMars TGO used its Cassis camera to capture a series of 5-second exposures. Mars Express attempted observations with its high-resolution stereo camera, though the exposure time of half a second proved insufficient for detecting such a dim, distant target. On October 7th, 4 days after the Mars flyby, ESA released the Cassis images publicly. The scientific community and space enthusiasts who had been waiting with anticipation finally had something to examine. What they saw was a fuzzy white dot moving across a star field. Background stars appeared as streaks because Cassis tracked the moving comet during the exposure. 3 Atlas itself appeared as a slightly elongated blob, bright in the center, diffuse at the edges. The images confirmed 3I Atlas existed, confirmed it had passed by Mars as predicted, but revealed little about its structural composition. Nick Thomas, principal investigator for the Cassis instrument, explained the challenge. Cassis was designed to photograph the bright surface of Mars from just a few hundred to a few thousand kilometers away. Pointing it at a dim object 30 million kilometers distant pushed the instrument well beyond its intended operating parameters. The comet appeared roughly 10,000 to 100,000 times fainter than typical targets. The fact that Cassis detected anything at all demonstrated impressive versatility, but the resolution was limited. A Vibe analyzed the Cassis images in detail. He noted that the width of the bright glow around 3 Atlas in those pictures measured about twice the diameter of background stars in the same frame. Given the angular resolution of Cassis, this translated to roughly 680 kilometers of visible coma. That's an order of magnitude smaller than what Hubble had observed. But Hubble had much longer exposure times and much larger aperture. Cassis could only detect the brightest central region, missing the fainter outer envelope that extended much farther. The interesting detail Loeb pointed out was that the extension of scattered light around 3I Atlas appeared qualitatively similar to what Hubble had captured back in July, just compressed into a smaller apparent size due to instrumental limitation. The data suggested no major increase in outgassing had occurred over the intervening months. If 3 Atlas were a typical comet approaching the Sun, you would expect activity to ramp up dramatically as solar heating intensified. The relatively stable appearance implied either the object wasn't responding to solar heating the way normal comets do, or its response was more subtle than expected. Meanwhile, speculation about NASA's images intensified. 7 spacecraft had been in position. The Mars Reconnaissance Orbiter's high-rise camera should have captured extraordinarily detailed views. MAVEN's ultraviolet spectrograph should have mapped the gas distribution, yet nothing appeared in public archives. The automated raw image feeds from Perseverance rover continued updating, showing the usual surface geology of Jezero crater, but no official processed images of 3 Atlas materialized. On October 4th, just one day after the flyby, something appeared in the Perseverance raw image archive that caught attention. The right navigation camera, one of the rover's nav cams used primarily for surface navigation, had captured an image at 2133 local solar time on Mars. The image showed an elongated streak of light against the dark sky. The timestamp coincided with when 3I Atlas would have been visible from Mars. Amateur astronomers immediately began downloading and analyzing the image. Simeon Schmaus, an astrophotographer who regularly processes publicly available space mission data, stacked multiple NAVAM frames together to boost faint details. He identified what appeared to be a smudge of light in the constellation Corona Borealis, close to where orbital calculations predicted 3I Atlas should appear. Stephen Burns created a 9-minute time-lapse by stitching together sequential NavCam images showing a bright object moving across the Martian sky. But the morphology of that streak raised questions. The object in the NavCam composite appeared roughly 4 times longer than it was wide, creating a cylindrical or cigar-shaped appearance. Social media erupted with comparisons. Someone noted it resembled the Doomsday Machine from the 1962nd Star Trek episode, a massive cylinder that consumed planets. Others pointed out the similarity to Oumuamua, which had also displayed an elongated shape, though MO's length-to-width ratio was closer to 10:1 based on its light curve variations. Was 3 Atlas actually cylindrical, or was something else creating that appearance? A Vibe addressed the question in a detailed analysis. He calculated that the NAVAM image was likely a composite stack of hundreds of individual frames taken over approximately 10 minutes. During that time, 3I Atlas would have been moving across the Martian sky at significant apparent velocity. Mars orbits the Sun at 24 kilometers per second. 3I Atlas was traveling at 67 kilometers per second relative to the Sun in a retrograde direction opposite to Mars. The relative velocity between the comet and Mars translated to a path length of roughly 50,000 kilometers over a 10-minute integration period. If amateur astronomers stacked all those frames together without accounting for the object's motion, they would create a streak. The length of that streak would depend on how long the stacking process integrated, not on the actual physical dimensions of 3 Atlas individual snapshots, and NavCam's maximum exposure time of 3.28 seconds would show 3 Atlas as a roughly circular spot. Stacking them creates the illusion of elongation. Think of it like photographing a car driving down a highway at night with a long exposure. The car itself might be compact, but in your photo, it appears as a long streak of light. The streak doesn't represent the car's actual shape, just its motion during the exposure. The same principle applies here. The cylindrical appearance in the amateur processed images likely results from motion blur, not from 3I Atlas being physically elongated. Still, NASA hadn't confirmed whether the NavCam images even showed 3I Atlas. The agency remained silent. The featured image of the week on NASA's Mars Reconnaissance Orbiter page